Welcome to this section next on the series of lectures on gas laws. For this, you're going to need your pencil or pen and paper, and you're going to need your calculator, and you are going to need your red, white, and blue periodic table. That's going to be a must for you also. As we go through this section, please pause the video as necessary to write down concept questions or application questions or clarity questions that you may have. Hopefully, we will cover those in this lecture, but if we do not, please make sure that you address this with your instructor before we go on to any other section or activities for this particular unit. Okay? First of all, let's talk about what gas density is. Gas density, well, we know density is a physical property of matter, as the element or compound has a unique density associated in grams per milliliter. This is what density is equal to. Okay? We know that. But when we're looking at comparisons of density, the density of several gases can be compared to air, and most often we use them in comparison to hydrogen. When we do that comparison, we're trying to look at three things. Does it float? Does it sink? Or does it hang suspended? If an object containing a gas floats in the air, that means that it is less dense than air. If it sinks, that means it's more dense than air. And if it hangs suspended, it has the same density as air. So when we look at the density of a gas, we're actually looking at a gas that has, let me put this way. There we go. There we go. A gas that has the same number of molecules. Well, we know that all gases, and pretty much everything that has volume of gases, is going to be 6.02 E23 particles of that gas. And we know that 6.02 E23 particles of that gas is going to be the same for every gas. So whether we're talking about hydrogen gas, or I'm talking about carbon gas, or I'm talking about, chlorine gas, if I take 6.02 E23 particles of each one of these and I compare them and put them in air, I can determine whether that gas is going to float in the air, whether it's going to sink in the air, or whether it's going to hang suspended in the air based on looking at their densities of the gas, and the difference in their molecular weights are going to determine whether the higher molecular weight is the higher the density, but is it high enough to be sinking in air, or is it not high enough as the density of air where it's going to float in the air, or is it at the same density as the air itself that it's going to hang suspended of air. So these things vary depending on molecular weight or the mass of that. So two things when we look at the gas density. We're looking at the amount of gas particles, and we're looking at the molecular weight or the mass formula of these particles. Okay? All right, so let's look at this. First of all, most of your gases stand alone. If your gas was something like argon and krypton and helium and carbon, these things stand alone. But we do have that group of gases, which we all need to make sure we always remember, which we call Han and the halogenettes. And that is hydrogen, oxygen, and nitrogen. There's your Han. And then you have your halogens: fluorine, chlorine, bromine, iodine, astatine, and the new one, of course, which is oganesson. Those are all considered to be your halogenettes. Han and the halogenettes are what we call the diatomic molecules, and this should just be review for you. These are diatomic molecules. These are molecules that cannot stand alone as a molecule. They cannot stand alone. They have to have the subscript 2, or they have to be diatomic, 2 atoms with each other. So make sure you keep that in mind as we go through, because if I'm talking about something that is a gas and it's one of the Han and the halogenettes, you have to know the formula in order to know the correct molecular mass of it so that you can do the density comparison. Okay? All right, so let's go ahead and get ourselves started. First of all, when you take gases and you place them in air, or in this case hydrogen, because we're going to be looking at both of them, the sinking, floating, or hanging suspended is based on the hydrogen or the air standard. Now, the hydrogen and the air standard is going to be basically the density of hydrogen, the molecular mass of hydrogen, and the density or molecular mass of the air when you do the comparison. Well, you know, when you're doing a comparison, you're usually using a ratio, right? Okay, so if I have something to air and the ratio is less than 1, or greater than 1, excuse me, I know that that's going to sink in air or hydrogen. If the ratio is equal to 1, it hangs suspended in air or hydrogen. And then the ratio is less than 1, it's going to float in the hydrogen or the air. So let's look at the first standard for hydrogen. The standard for hydrogen is that whatever the number is, whatever the molar mass of a gas is, we're going to divide that by 2 because the molar mass of hydrogen is equal to 2. This is the molar mass of hydrogen. So we're doing a comparison, or what we call a ratio. So let's look at some gases. Hydrogen itself, in the presence of hydrogen, is going to be 2 divided by 2, which is equal to 1. That means it would hang suspended. But if I look at krypton and oxygen, krypton has a molar mass of 84. 84 divided by 2 is equal to 42. Well, that's greater than 1, so I know that krypton, the gas, is going to sink in the presence of hydrogen. And oxygen, or ozone, which is O3, which has a molar mass of 48, if I divide that by 2, that's 24. So that tells me that the ozone is also going to sink in the presence of hydrogen. That is with the hydrogen standard. The air standard, air has a molar mass of, and we just, through scientific calculation, we know that air has a molar mass altogether that is going to be equal to 29 as its standard. So if I was doing a comparison of those, determine the density of the following gases in air. Once again, look at hydrogen on your red, white, and blue periodic table. Find your hydrogen, find the molar mass of hydrogen, divide that by 29. That answer is going to tell you what the standard comparison of density is in air, and it will also tell you whether it's going to sink or float. So pause the video right now and do hydrogen and see if you can't give me the density as well as whether it's going to sink, float, or hang suspended. And then press play when you're ready. For hydrogen, you should have gotten 2 over 29, which is 0.07. Therefore, since it's less than 1 in density, it's going to float. Go ahead, pause the video, do krypton, and then come back and play when you're ready. Krypton is 84 divided by 29 standard of air. It is 2.90, which is greater than 1, so krypton sinks in air. Go ahead and do the ozone, and then press play when you're ready. Ozone is 48 divided by 29, which is 1.66, so it is going to sink because that's greater than 1. And go ahead and do nitrogen, and press play when you're ready to check. Nitrogen has a molar mass of 28. Divided by 29 is 0.97. So nitrogen is also going to float in air. But look how close nitrogen is to a standard of 1. So nitrogen is going to float, but it's so close to have been just hanging suspended in the air. So these are what we call our gas densities. Okay? Thus ends this section of your lecture notes. Again, if those questions you may have had were not answered by this lecture, feel free to rewind the lecture and go back through it. or make sure that you address those questions with your instructor. Have a great day. Bye-bye.